In this video, let us see how we can solve the additional practice questions for OPPE 2. Let's start with the grep questions. The first step that you have to do is go into your home directory and go into the SE2001 folder. Hopefully you have already created this folder. If not, you have to create this folder using the mkdir command. In this folder, you now have to create a folder for all these questions. So for example, you have to create a folder for Q-awk-1. Similarly, you have to create for all of these. So I've already created the folders for all the questions. So let me go inside QGrep1. Once you're inside a folder for a question, you have to type synchro show to see the question. So in this question, you're asked to create a script.sh which will take input from standard input and write output to standard output. In this question, you're given a markdown file in your standard input. You have to print all the headings in the file along with 2 lines after it. So some of the lines might also contain the line minus minus. So let us see how we can do this question. So in grep, if you want to print a few lines after or before a line that has been matched, you need to use the minus capital A, B or C commands. So if you go to man grep, you can find the capital A, capital B and capital C commands, which prints n number of lines after the print or before the match or both before and after the match. So this is first part of the question. You also have to match a heading correctly. So there are multiple things you have to keep in mind of how headings work in a markdown file. First thing is, a heading has to start with a pound symbol and there has to be a space after the pound symbol. So if you have something like pound heading without a space, that is a tag and not a heading. So we need to have pound symbol and then a space. And headings can be of 6 different indentations, and headings can be of only 6 different indentations. So for example, single pound, double pound and triple pounds are valid headings, whereas 8 pounds or 9 pounds are not valid headings. So you have to find only those lines that start with pound symbols present 1 to 6 times. So that is what we are doing in this script. We are searching for lines that start with a pound symbol present at minimum once and at a maximum of 6 times, and then there should be a space after that. So that is what we are searching for, and then we use the minus A to print 2 lines after each heading. Note here that when we run this on some file, for example, if I simply run grep minus E starts with pound 1 to 6 space and give A2, and if I run this on a file that has multiple matches, what grep will do is it will separate the matches using a minus minus sign. So here you can see we are printing a line that has one heading followed by 3 lines and then another heading. So if I run this using the grep that we have written, then as you can see it will print the first match and 2 lines after it, and then it will separate the first match with the second match using a minus minus. But we don't want this minus minus to be present. So one way to avoid this is to simply not print any lines that starts with minus minus and there is an end of line after that. So this will accomplish what we are trying to do, but as the question states, some lines might also contain the minus minus. So if we do that, then that will not satisfy those test cases. So for example, if I set the script such as we are inverse matching the lines that has only minus minus in it. So you can see if you do synchro eval, it matches the first and second test cases, but the third test case does not match. So we are expected to have a minus minus, but we don't have that in our output because the minus minus here is part of the data itself. So you can confirm that by printing the test case files itself. So you can do cat opt SE2001 base name pwd, and here you can print all the test cases, and you can see that the third test case has, so here you can see the third test case has a minus minus in the data itself, and you're supposed to preserve that. So for that reason, you are unable to remove simply lines that has minus minus. So the better way to do this is using the dash dash no group separator flag. So you can see in the man page itself, you can either set the group separator to be any other character, or you can totally omit a group separator by using dash dash no group separator. So that is how we solve this question. So now you can see all the test cases have been passed. Let's go into the next question now. So in this question, you are given an access log file, and from this you have to print out the IP addresses, and the IP addresses should only be the unique IP addresses, and you also have to print the count of those IP addresses and the printing of the IP address and the count of the IP address should be in the descending order of the count. So here we have an example input and an example output. So you can see the IP address is the first field in each of these lines. So first what we have to do is we have to extract the IP address. To do that, we can either use cut, so we can cut by a space and take the first field. So we can do cut with a space as delimiter and take the first field, or we can use a regular expression in grep to match the IP address. So we can say grep OE, O is for printing only what is matched and not the entire line, E is for extended regex, starts with 0 to 9 as in a digit, present 1 to 3 times. So each octet can have a minimum of 1 digit and a maximum of 3 digits, followed by a literal dot, and then the same thing present 3 more times. So this matches an IP address, and only the IP address will be printed. So this is same as using the cut here. After we have the IP addresses, we now have to sort the IP addresses, because we have to also use the unique command to get the count of the IP addresses. So unique expects a sorted input, so we have to first sort it, and then we have to pass it through unique minus C to get the count of the IP address. So we get the IP address, unique IP addresses, and also the count of the IP address. So now the IP address will be in sorted order of the IP address and not of the count. So thus we have to again pass it through sort minus NR. So N is for numeric sorting, so we don't want to sort it as alphabet, we want to sort it as a number, and we sort it in a descending order. So we don't have to specify any field separator or which field to sort by, because the field we want to sort by is always the first field itself. So we can simply call sort minus NR to sort the files. And then the output of the unique C has a lot of spaces at first. So in order to remove that, you can either use TR minus S space to squeeze those spaces. So let us see one of the input test cases. So I can go to /OPPE SE2001 base name PWD, and here I can print the tc00.in, and you can see this is the sample input that we have. So let's perform the actions that we were trying to perform. First we will take only the input IP addresses. So we split by space and we take the first field. So now we have the IP addresses, but as you can see we have duplicate IP addresses. So then we sort the IP addresses, so the duplicates are present one after the other. As you can see, all the duplicates are consecutive. Then we can use unique C to get a count of all the IP addresses. So you can see we only have these many unique IP addresses, and these are the counts of those. So right now the output is still sorted by the IP address and not by the count. So now we can again pass it through sort NR. So we need to use NR and not simply sort. So if we simply use sort, then as you can see, this will sort it alphabetically and as is increasing order. So it starts with 1, and 13 is also considered in that same range, and then 17, and then 2, 3, 4. So if I use N, then this sorts correctly using a numeric sort, and we want to sort it in a descending order. So we can either pass this through TAC to get it in a descending order, or we can simply add a R flag to sort it in a descending order. Then we have a lot of spaces here. So to get only this and this field, there are multiple ways we can do. We can use awk, and we can simply ask it to print $1 and $2. This will remove the spaces automatically. Or we can use tr-s to squeeze the spaces. So instead of having so many spaces, it will always have one space. And then we can simply use cut minus d space minus f2 dash to get everything except the initial space. So this is how we can solve this grep 2 question. Instead of using tr and s, we can also use regular expression to solve this. So we can again, similarly how we match IP addresses, we can match any number, present any number of times, followed by a space, and then again IP address. And because we are using O, it will only print that and not the initial spaces. So this is how we solve the second question. Let us now see how we can solve the grep 3 question. So here the question states that you are given the same access log file, and you have to print how many users are accessing from Macintosh, how many are accessing from Windows, how many are accessing from Linux, and how many are accessing from iPhone. So to do this, we have to store the file that we are getting as standard input first as a file, and then we iterate over it 4 times, and we search for each of these one by one. So there are multiple ways of doing this. A few of the solutions are listed. We will be discussing this simple solution, where first we store the entire file that we are getting into a file. So we get the input as standard input, but we can pass it through cat and store it as a file. We also remove that file after processing everything, and then we simply create a for loop where we run over all the 4 operating systems we are interested in, and we use grep to count the occurrences of that operating system in the temporary file, and we use -w to match whole words and not subpart of words. and we use minus C to print only the count of the matches and not the matches itself, and we then print it in the correct format. This is the way of solving this question. Let us now see how we can solve QGrep4. So in this question, you are given the same access log file as the previous two questions, and now you have to print the HTTP words that are being used. So in the previous question, if you had some output which was 0, you were supposed to print the number as 0 itself. So that is how grep would have worked. But in this question, if there is some verb which is not present at all, that is the count is 0, you are not supposed to print that word at all. So the solution to this is also pretty similar to the last one. So let's go over the solution. We again store the file in a temporary file. We go over all the verbs, and then we first store the all the verbs that are there. So we search for the verbs. So we are iterating over the verbs, and we use grep minus wc, same as the last solution, to find the matches where we have the verb followed by a space and /. So the / is required, otherwise there will be miscounts, because there will be some requests which have the word get in it, but it is not a get request. Similarly, it might have the put or delete in it, but it is not a put or delete request. So we have to actually match the correct request verb and not part of any other part of the line. So we then echo everything just as the previous question, but here now we pipe the output of this for loop into grep, where we are matching for any line that does not end with a 0. So we have a grep which is searching for space 0 and then end of line. So we are searching if there is any output which has the space and then a 0 and then a $, that means that verb is present 0 times. So we are not printing those. So we are using -v to inverse print those. And also here it is told that the output should be in the descending order of the count of the HTTP verbs. So for example, the highest should be at the top and the lowest should be at the bottom. So in this case, we have to, because it is the second field and not the first field, we have to provide the k value to sort. So here we are providing sort minus k2. So k mentions which column to sort by, and we are also mentioning nr to sort it numerically and sort it in a descending order. So in this case, we don't have to mention minus t, because the delimiter is the default delimiter, which is white space. If it were some other symbol, then we will also mention that with minus t. So that is how we solve the question 4 of grep. Let us see now how we can solve QGrep5. So in this question, you are given the same access log as the previous question, and in this, what you have to do is you have to print the count of the hours at which requests were sent along with the hour. So for example, these are the hours: 04, that is 4 AM, 00, that is midnight, and these are the counts, how many requests were sent at that time. And your output should be in descending order of the count of requests per hour, so similar to what we have done so far. And the output should only show hours having more than 9 requests. So if some hour has less than or equal to 9 requests, that line should not be printed. So let us see how we can solve this. So first we cut the input using a colon, and we take the second field. So let us see what is the type of the input that we have. So we can go into OPPE SE2001 base name PWD, and we can print the tc00.n. So you can see this is the same test case input, and here the hour is present here. So if you split the line by the colon symbol, then everything to the left of this first colon is field 1, and only the hour is the field 2. So we can simply use cut the colon F2 to get the hours. So then after getting the hours, we also have to sort it and unique it, and then again sort it, similar to the previous solutions. So we do that to get the, first we get all of the hours in the same consecutive lines, then we find how many unique hours there are. So this gives us something like this, and then we need to also sort it according to the descending order of the number of requests. So now we have to remove this one which has 9 requests. So to do that, there are multiple ways. You can either use a loop to go through each of these and then see whether the number is less than 9, or you can simply use regex. So because any number less than or equal to 9 will be a single digit, and any number greater than 9 will be a double digit, you can directly check how many digits there are. So we can only print those lines that have digits present 2 times or more, followed by a space and then any number of digits present any number of times. So the second group is the hour. So ideally this should be present only 2 times, but we can also use a plus here. So now you can see only the 9 and 202 is dropped, everything else is present. And we also had some extra spaces in the front, and that is dropped because we are now using grep O, so only the matching part is being printed. if we did not have grep O, then the space would also be printed. So this is our solution now, and this is how we pass this test cases. Let us see now how we can solve the bash questions. So let's go into Q bash 1. So in this question, you have been given the HC password file as your standard input. You have to read each line one by one using a while loop and a read command. In this, then you have to perform the following tasks. First, you have to see if the line is a comment, then you have to skip it. So comments in that file starts with a pound symbol. If that line is not a comment, then you have to print the username and the home directory of the user. But if the user has a description, which is also called a comment, in the GCOS field, which is the general information field of a user, which is the fifth field of the HC password file, then you have to print the description instead of the username. Now, if the home directory of the user is of the form /home/username, which is usually the case for most users, then we print /home/$user. So we print this $user thing literally. So we don't actually substitute any values here. And if not, then we print the entire home directory path. And if we are not printing the username, that is, if we have a description field, then we should print the home directory as it is, either way. So your script should only print regular users, not system users. So regular users are users who have the UID greater than 1000. And your script should also delimit records using --. So because we have multiple users, we should delimit the records with --. So this is how we solve this question. First, we have to print the text users. So how do we know how to format the output, like how whether to write username or not, whether to write home directory or not, whether to write comment and these users or not? So all this you can check by seeing the expected outputs. So you can go into the /OPPE SE2001 base name PWD, and here, depending on your questions, so for NPP the folder structure might be different. For these questions, it is in the tc00 etc. .out. So if I simply do *out, so you can see there is only one test case, and the expected output is of the following format. So you can clearly see how the output is supposed to be formatted. So we print this text users always at the top, and then we read each line. So we do read line with a -r to prevent mangling of backslashes. And then for each line, we first have to check if it's a comment or not. So a line is a comment if it starts with a pound symbol. So we can do this matching inside the double box bracket shell built-in keyboard. And if it is a comment, then we continue. If not, then we read each line of the HC password. So let us see how the HC password file is structured. So you can see the HC password file has the fields delimited by a colon. So that's why we have to set the IFS to be colon before reading each of the values from the line. So we can, instead of using cut to split it, and instead of writing cut 7 times, we can directly use read -r and give all the variable names, and we can give the input to read directly from this string by using the triple less than symbol. And so that read correctly splits using colon, we have to set the IFS to be colon. So now all these variables store all the values for each line. So first we will check if the UID is less than 1000, then we obviously continue, as this is a system user and not a regular user. And then we print --. So this is the delimiter between each record. And then we have to perform the following checks. If there is a comment, so -n means non-zero length of a string. So if the comment is of non-zero length, then we print comment and not username. Otherwise, we print username. So then we check if if it is a comment, then we obviously print comment. If it is not a comment, that means we have to print the username. Then we also check if the home of the user is same as /home/username. So if that is the case, then we print $user, and to print the literal $user, we have to escape the $, and we print the username. And even if this is not the case, we still print the username, and we then print the home directory in all the cases of the above. So this is how we solve this question. Let's see now how we can solve the bash 2 question. So in this question, the test cases have been changed. So here we have to create a script.sh where we have to take input from standard in and write output to standard out. So you're given a heart attack data, and from the data you have to find out the outliers in the data in the heart rate field. So the heart rate field is the third field of the data, and the data may or may not have a header row. So your script should work either way. And the heart rate field is the third field, and it is always an integer. An outlier is an value that is more than 1.5 times the IQR from the Q3, or less than 1.5 times the IQR from the Q1. So this is the structure of the CSV file, and and all of these are integer values, so we don't have to worry about any field separator. So we can see some test case. So we can do cat. So we can see some of the test cases by doing /opt/se2001 base name twd, and the location of the test cases might be different depending on the questions. So for these questions, they are simply present in that folder as TC. So I can print them out. So you can see this is the first test case where we have the header and we have around 131 lines of data, and the output has 4 lines. So these are the lines. As you can see, this is clearly a mistyped data, so this should be 111, but it has been entered as 1111. Obviously this is not humanly possible to be a heart rate, so that's why this is part of the outliers, including 125, 125 and 135. So similarly you can see for all of them. So we can see only the outputs. So you can see usually there are only a few lines, whereas the inputs are 131 lines, and for some test cases there might be no outliers at all. So let's see how we can solve this question. So first we are taking the standard input that is given to us and storing it in a temporary file, which we are deleting at the end. Then we are using sed to find a line that starts with age. So if you remember, that is the header line. So we are seeing if a header line exists, we drop that line and we are doing it in place on the data file. Then we are sorting the file based on the third column. So we are using the comma as a delimiter, and we are asking it to sort based on only the third column. So K3, means sort with the third column and only the third column. So this will not work if we use K3, which means start sorting from the third column, but it will also include the columns after the third column. So if you want to sort based on only the third column, then we have to use K3, 3. So we need to sort the data based on the third column, because to find out the quartile 1 and quartile 3, we have to have a sorted data. We also need to sort it numerically and not alphabetically, and we also set the output of the sorting to be also the data file. So we cannot directly redirect the output of sort into data, because that will create a conflict and the file will become empty. But we can use the -O flag in sort to directly have the sorted output stored in the file itself. Then we read the file. So we take the file and we cut it by commas, and we take only the third field, which is the heart rate field. So we do it on the data. So we run cut on the data and we split by comma and take the third field, and that output is then taken as the input to the map files. So we use map file to take the data that is given to us and store it in a array. So we are using this heart rates array, and we are storing all the lines into this array. Then we store the number of elements in that array in a variable called lines, and then we simply find the first and third quartile. So we check if there are even number of elements, then we do it this way. If there are odd number of elements, then we do it this way. So if there are even number of elements, we can directly divide it by 4 to get the Q1, and divide it by 4 and times 3 to get the Q3. Whereas if there are odd number of elements, then we also need to add 1 to it. So once we have the index of Q1 and Q3, we can also get the value of Q1 and Q3 by accessing that element in that array, and we can find the IQR by subtracting Q3 minus Q1. We then have to find the lower and upper bound, so that is nothing but Q1 minus 1.5 times IQR and Q3 plus 1.5 times IQR, and then we print only those numbers which is lower than the lower bound or higher than the upper bound. So we can do that with awk by setting the field separator to be comma and passing the two variables, which is lower and the upper, into the awk, and we run it on the data, so we get the output. Instead of using the awk, we can also use a while loop to read each line from the data, and we can then split the file with comma. So we can set IFS to be comma and read each variable, age, gender, heart rate, etc. into the variables using the read and the triple less than sign, and then we can check if the value is less or more using BC. So this will be slower because we are reading line by line, whereas awk is more efficient. So the awk solution is faster than the while loop solution, but both of them will give you the correct answer. So in this, the test cases have been changed. So if you have solved this question before this given time, please try to solve this again and evaluate your script with the correct test cases. So let us see how we can solve the Q-3 question. So in this question, we are told that we have to write a script.sh that takes input from standard in and write output to standard out. We have been given two files, file 1 and file 2, but obviously we are reading the input from standard in and not accessing some file in the current directory. So how do we differentiate between file 1 and file 2? So we are told that the contents of the two files is separated by EOF, and our job is to then print the differences between the two files and the commonality between the two files, and the order of the output should be same as the actual file. So in this, if we first print out the test cases, so you can see that the file is, the input is given this way. So after first few lines, then EOF, and then again a few lines. So the lines before EOF is the file 1 and the lines after EOF is the file 2. And as you can see here, we have orange present both in the first file and in the second file. So output should be orange is common, and then we print lines that are unique to file 1 and lines that are unique to file 2. So to do this, we can simply use grep to do this. So let us see what is the solution. So first we read each line and we store them in a separate file. So we till we find an EOF, we store it in file 1, and once we have found EOF, we then store the rest of them into file 2. So there are two ways of solving this. If the input is already sorted, or if it is possible for us to sort the input, as in the output's order is not important, then we can use the com command, which is COMM, and we can specify which things to check. For example, I can ask com -1 2. So this means remove elements from the Venn diagram which is in the first part and the second part. So how are the parts defined? So in a Venn diagram, we have elements of set A and we have elements of set B. So this is A and this is set B, and whatever that is common to both, so that is the intersection. So this is the intersection. So this left part is numbered 1, this right part is numbered 2, and whatever is in between is numbered 3. So if you want to print only what is common, you simply remove the part 1 and part 2. So for intersection, we do com -1 2 because we are removing part 1 and part 2. For A minus B, so this is the set notation for A minus B, we use com, and here we want to have A, so we want 1 and 3, but we don't want B, so we don't want 2, and we also don't want 3 because 3 is also part of B. So A minus B is only the part 1, so we subtract 2 and 3. Similarly, B minus A is com -1 3, so we remove part 1 and part 3. So this is how we can use com to get the intersection and different set differences, and we can also get the union, and we can also get the nothing that is there by doing -1 2 3. So in this case, we cannot use com because neither is the data sorted nor are we allowed to sort it. So if you remember, the question asks us to keep the order of the output unchanged. So then we have to use grep instead of com. So here we can use grep -fxf and give the two files. So this works because we are asking grep to treat the pattern file also as a fixed string and not a regex, and x as in we are asking that the pattern should be present exactly in the entire line and not as a substring of the line, and f meaning this is the pattern file and this is the file that it searches into. So if you're searching for a pattern that is a fixed string and matches the entire line, so that is same as asking if a line matches from file 1 in file 2. So the first one prints all the lines that are common in both file 1 and file 2. So the next two lines prints files that are present in only one but not the other. So unique to file 1 is grep fvxf. So here we are inverting the match. So we are telling things that are not present in file 2 but in file 1, print those. And similarly, unique to file 2 is fvxf file 1 file 2. So in the end, we remove the extra files that we created. So that is how we solve this question. Let's see how we can solve the last bash question. So in this question, you have been given the advertising dataset, a very popular dataset of the ISLR book, and you have to perform the linear regression on the dataset to predict the sales using the TV as a predictor. So here you have three variables: TV, radio, and newspaper. But if you are familiar with the dataset, as you can, so if you are familiar with the dataset, radio and newspaper are not correlated with sales at all, whereas TV is very highly correlated with sales. So we run a linear regression on TV to predict the sales. So we're using TV as a predictor, and we have to print the coefficients of the model. So for a single linear regression, the coefficients of model are nothing but the intercept and the slope of the line. So we accept the dataset from the standard input. So let us see how we can solve this question. So first we are ignoring the head or the header because that is not part of the data. So if there is a header, we simply drop that, and we are also removing all the carriage returns. So this data set also has carriage return in it, and if you have carriage return in it, it will mess with your data. So you have to use the call command to remove the carriage return and only have the line feed. So we do two tasks in this one line. First we remove the header, and then we remove the carriage return from all the lines, and then we store this as a temporary file in data. And then we are storing two arrays, x values and y values. So we are reading the array values from the file itself. So we are cutting the file using comma and taking the first field, which is the TV. so that is stored as x, and we are taking the fourth field, which is the sales, and we are storing that as y. So now we can get the number of points by taking the length of the array, and we store the sum of x and sum of y to be 0. Then we perform a linear regression. So this is the algorithm for linear regression. We calculate the sum of all the x's and sum of all the y's by simply summing the values, and we then find the mean of all the x's and mean of all the y's by simply dividing the sum by the number, and then we have the numerator and the denominator. So this is the formula for simple linear regression. We get the difference of x, so the difference of each data point from the mean, similarly the difference of each data point of y from its mean. And so now that we have the x difference and the y difference, in the numerator we simply add all the x diff times y diff, and in the denominator we add all the x diff squares. So x delta y by delta x whole square is the numerator and the denominator, and the slope is simply numerator by denominator, whereas the intercept is the mean of y minus slope times mean of x. So this is how we get the slope and the intercept, and for this we have used scale 10. You can also use other scales, so make sure you're using at least more than 2 or more than 3. So if you don't have precision in your output will be rejected, but your output does not need to match exactly. So in the end we are printing the intercept and the slope. So this will match all the test cases, and you will be getting a successful evaluation. For example, in this case, if we change the scale from 10 to let's say 3, so in that case also this will pass all the test cases. But if you reduce it further to some other level, so for example, if I then reduce this 3 into let's say 1, so then this will not work for some of the test cases. So as you can see, many of the test cases will not work because your answer is very less precise. So make sure you're using a high scale value. So I've used 10 in this case. So that is how we solve the last batch question. Let us see how we can solve the SED questions now. Let's start with SED 1. So in this we are given a SPICE message which is encrypted using the ROT13 technique. So ROT13 or rotation 13 is a kind of Caesar cipher where letters are simply substituted with some other letter. So ROT13 is a special kind of cipher because here you are increasing the value of each letter by 13. So if you remember, English alphabet has 26 letters. So what this accomplishes is the cipher becomes symmetric. So if you add 13 to a letter, for example, A becomes N, but then if you add 13 again and it wraps around, from N it becomes A again. So if you perform ROT13 on some data 2 times, then you get back the original data. So that's why ROT13 is a special kind of Caesar cipher. So given a ROT13 input, you have to print the ROT13 of that, or the decoded output. So in this you have to use a sed script. So if you create a script.sh, that will not be used. You have to only create a script.sed. So let us see the solution for this. You simply have to use the y command in sed. So just like we use s command to do a substitution, we can use the y command to do a transliteration. So this is same as how the tr command works. So if you give, let's say, the urryb to the tr command, so here I can ask it to translate the a to z into n to z and then a to m. So then you can see, sorry, this should be uryyb. So then you can see it has successfully performed a ROT13 on it, but unfortunately we cannot give ranges like this in sed. So although this is exactly what sed y does, we have to explicitly mention the range. So as you can see, we have to give a to lowercase a to lowercase z and uppercase a to uppercase z, and we should substitute those with n to z and then a to m. So once this transliteration is done, this will successfully give you the correct ROT13. So that is how we solve this question. Let's see now how we can solve SED 2. So in this question we are asked to unfold lines. So if you have watched the lecture on SED, you will remember this is something that the professor has gone through. So here in this, what we have to do is we have to keep on checking if the last line is a backslash or not, and as long as there is a backslash in the last line, we will first take the next line in our pattern space. So in SED, by default, each line is taken in the pattern space one line at a time. So you will never actually have the new line character in your pattern space because the SED takes only the value of the line and not the new line. But then if you are using the n command, the next line also comes into the pattern space. So now the pattern space contains the first line, the backslash n, which is new line, and then the next line. So now we can use a substitution on backslash n and make it so we can remove that. So what we can do is we can substitute the backslash and backslash n. So to match a literal backslash, we have to escape the backslash. So we have to substitute backslash 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 n with nothing. So we remove the backslash with a, and then new line with nothing. So we should keep doing this. We cannot do it only once. So for example, you can see there might be lines that are folded multiple times. So we have to keep doing this. So to keep doing this, we have to utilize the feature of branching. So we have to first create a label with the colon symbol. So X is a label, and then we first take the next line in our pattern space. So notice that here we are using n unconditionally. So we are even going to use n on the last line of the input. This is not something that is defined in POSIX sed, but because we are using GNU sed, this works correctly. So this will not give you an error if you are running capital N on the last line, because there is nothing else to append to the pattern space. So we are simply appending the next line to the pattern space, and if there is a backslash new line, so in that case we will substitute that with nothing. So if there was a backslash new line and we substitute it with nothing, so then we will conditionally branch. So this T as opposed to B means a conditional branching. So we will only go here if this thing is successfully substituted. So if this is successfully substituted, so there might be cases where we have unfolded one part of it, but we still have to do the next one. So that's why we should again branch back and we should again take the next line. So imagine we have done for the first two, and then we take the next line and again we substitute the backslash 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 n with nothing and we unfold this line. So imagine if there was something else after this, so then we would go back again and we would have again taken the next line into the pattern space, but that is not something that we want. So we just want to print each line one by one. So in that case we will obviously not have this pattern match, so we will not have a backslash and a new line at the end. We will just have a new line between the two lines. So this substitution is going to fail, and thus we will not conditionally branch to X. So then we will go into the next one, and here we first print everything in the pattern space till the new line. So remember that we will have, let's say, everything till the first line, but we will also have the next line's first part in our pattern space, and we don't want to print this entire thing. We only want to print till the end of the line. So we use P to print only till the new line, and we remove the extra part that was added to our pattern space, so that in the next cycle of sed we again have that as the first line of that cycle of the sed. So this is one of the solutions where you need to understand how P, D and T works. So this gives you the solution. There is also another solution which would be simpler than this. So there is another solution to this. So because in this we are always unconditionally appending the next line into the pattern space, we might sometimes make the mistake of appending a line that we should not, because there might be sometimes lines that don't end with a backslash. So in that case also, if we are appending by mistake, then we basically don't branch, so we won't be able to substitute and we don't branch back, but instead we first print everything till the new line, and then we delete the rest part so that we can again iterate over that first part of the next line in our next cycle. But instead of doing this, what we can do is we can check whether there is a backslash at the end of our line. So first we can check if there is a backslash at the end of our current line, and only then do we use the n to append the next line into our pattern space. So because we are only appending the next line into our pattern space when there is a backslash in our current line's last character, so thus this substitute will always work, and thus we don't need to use a conditional branching. We can also unconditionally branch to the X label, and thus we don't need to use P or D to print the mistake or remove the mistake. So this will also pass the test cases. So these are the two solutions for QSED 2. So let us see how we can solve QSED 3. So in this question we have to perform the following operations on the given file. First we have to replace all occurrences of the word the with the word this, and then we have to add the text hash minus 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 before each function definition. Thirdly, we have to add the copyright information at the beginning of the file, and finally we have to add the line number as a comment after every 5 lines. So this is the hardest part of this question. All the other 3 are pretty simple. So also the definition of how a function should be identified is given here. So although this is a sed question, we are asked to create a bash script. So this might be one of your first hint that this is not possible to be done with a single sed command. So here you have to use multiple sed commands to accomplish this. So let us go through the solution now. So for this we are using two sed scripts. So this is our script.sh that is being called. So we have broken it down into two sed scripts. So we are simply calling sedf script.sed and passing output of that into sedf script.sed. So this is script 2 and this is script 1. So first, every other thing is performed by the script. So in the first line we are inserting the copyright information. So we are adding the copyright information at the beginning of the file. Then we are substituting the word the with the word this globally, and we are doing this with word boundary because we want to only substitute the word and not any occurrence of the in any other word. Thirdly, we are doing the function identification here. So we are searching for any pattern that starts with 0 or more space, then the word function followed by any character. So this can be the name of the function, then the opening and closing brackets. So we don't have to escape this because this is BRE by default and round brackets are literal in BRE. So then again we can have 0 or more number of spaces, and then we have the opening curly bracket, and then again we can have 0 or more number of spaces. So after that we should have the end of the line, and then if we find such a pattern, we insert the hash minus 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 before that function definition. So these three are the first three tasks to be done, and for the last one we have to, for every fifth line we have to add the line number as a comment. So this is done in two parts. First we are adding the hash sign, which is adding the comment, and then we are using the equals to print the line number. So if we directly do I hash equals, then it will not print the line number, it will print equal to sign. So we have to, because equal to is a command, so we have to use equal to print the line number, and we have to use I hash to print the hash symbol. So this will have hash and the line number on two different lines. So then we use the second sed script, which simply searches for the line that has only one hash, and it then concatenates the next line into that same line. So we simply read the next line into the pattern space, and then we substitute the new line with a space. So that is how we solve this question. So in this solution there should be only two box brackets here and not three. Let's see how we can solve the fourth question. So in this question you are given a CSV file where we have 5 fields: name, age, gender, city and address. But the address field contains multiple lines of text, and because of this it is not escaped, but then it is directly given in the data that way. So for example, we can see one of the test cases. So you can see we have the first line, which is the header, and the next line, this is the first data. So this is the name, age, gender, city, and then this is the address. So the address field is always quoted, and you can see the quotation starts here, and this is the first line of the address, and then we have the second line, third line, fourth line. So you can see this is not a structured CSV because we have lines which are part of the data, but they're not a different record. So this is the first record, then this is the second record, this is the third record, etc., and this is the fourth record. So for this one we have it in one line itself. So our job is to make them into one line. So the question asks us to remove the new line and make it into a comma and a space. So address field should be stripped of new lines and quoted. The new line should be replaced with a comma and space. So the address field is already quoted and the quotation should remain, and instead of new lines we should have a comma and a space. So let us see the solution for this. So in this also we require branching, because if you remember, the test cases will have variable number of lines. So in some cases we need to merge 4 lines, whereas in some cases we don't need to merge at all, whereas in some other cases we may need to merge only 3 lines. So we cannot hard code any number of times we should run the n, so we have to run it like a loop. So in this we will set a label for the goto, and then we do all this for all lines except the first line. So this is because the first line will never have a quotation at the end, but that does not mean that we need to append some other lines to it. So first line is a header, and the header address is obviously is not quoted because this is just the name of the column. So we do this for all lines except the first line. So one exclamation means we do this following thing for all lines except the first line. So then we search for any character that is not a quotation at the end of the line. So notice that if it is quoted correctly, so if it's a single line, then the line will end with the closing quote of the address. But if it is not like this, then it will not end with a closing quote. So if the line does not end with a closing quote, that is not a quote and then the end of the line, then we first take the next line into our pattern space, and we substitute the new line with a comma and a space as per the question, and then we simply conditionally branch into the label here. So here we can use B or T, so unconditional branching or conditional branching, because this will always so this substitute will always work because we are substituting new line, and if we are doing n, then the substitution of new line will always work except when we are on the last line. So in GNU said the n will not give you an issue, it will not give you an error, but if you are using POSIX said, you should also check if this is the last line or not. So if this is the last line, then you should not do this, you should only do this for not last line. So this is the solution for this question. So let us see the fifth question now. So in this question, you simply have to pretty print JSON data that is given to you. So you have a minified JSON data, and this data object has a parent like enclosing object which has nothing but only one key called data, and that key has the JSON object that you are interested in. So it is told that the object that you are interested in is a single depth JSON object, and it does not have any nested JSONs. So assume there is no nested JSON objects, so we can directly assume that everything inside it should be indented to one level only. So this makes our lives easy, but you can also try to think how you will approach this question if there were nested JSON objects. So also look into the JQ command if you want to see how we can try to solve this for nested JSON objects as well. So for this question itself, we simply need to first remove the outer object and the data attribute here, because we just need to print the data attribute's value. So we first remove this, so this is told to be always present, so we can simply remove that, so we substitute that with nothing. Similarly, we remove the last brace, so we substitute the brace at the end of the line with nothing. Then we are left with only this part, so then we can simply substitute the opening brace with opening brace new line tab, and we can substitute each comma with comma new line tab, and we can substitute the ending brace with new line ending brace. So that is what we have done in these three commands. So that is how we solve the fifth set question. Let us see now how we can solve the OPPE questions. Let's start with QOPPE 5. So let's start with QOPPE 1. So here you can see the question. So you're given a data set of music. So you can see these are the music on Spotify, and the header format is given to you. So although the header will never be part of the data, but the header format is provided to you to understand which column to use. So you are a disc jockey at a local radio station, and your job is to create a playlist of songs. So you have a few criteria, because this is a New Year's Eve. You want to play songs that are released in this year itself, so of no other years, and you also want to play songs that people can dance to. So you have two criteria for that. Either the song should have a BPM of at least 120 and be in a major scale, or the song should have a danceability percentage higher than 80%. So you can see there is a danceability percentage column. So if this is greater than 80%, that is good enough. Otherwise, also for songs that have less than 80, if it is a song which has BPM of 120 or higher and is in a major scale, then you also will consider that. Provided all these conditions is only if the song is of the current year, because this is a New Year's party and you obviously should only play songs from that year. So then you have to first perform these operations using awk, and then you have to print only the track name and the artist name followed by a colon between them. So that is how the output should look like. So let's see the solution to this question. So here in this question you have to create a script.sh. So if you see the question, you have to create a script.sh. So although this is a awk question, you have to create a sh file. This is because you have been given a environment variable year. So you can either use the environ dictionary inside awk, or you can pass the environment variables into the awk script by using the -v flag. So for this question, this is how we proceed. So first we have set the fpat. So if you notice in this file, the file is contains comma as data as well. So you cannot simply set the fs to be comma, that will not work. If you want to work on CSV files that contains comma as part of data as well, so there the fields will be quoted obviously. So in that case you have to set the fpat instead of using fs. So you set the field pattern to be either any character that is not a comma as much as possible, or in case that the field is quoted, it should be quotation followed by any character that is not a quotation. So this includes comma as well, as much as possible, followed by a quotation. So these are the two ways a field can be. So remember that CSV file need not always be quoted for all the fields. Only if the field has a comma, it will be quoted. That's why we need to give both the regexes to this. And we also set the year to be the year given in the bash environment variable. So then the question is pretty simple in awk. We simply set the OFS to be space dash space as asked in the question, and we check if the year is the same as the given year and the scale is major and the BPM is greater than 120 or the danceability percentage is greater than 80, then we print the title and the artist, otherwise we don't print it. So this is how we solve this. A few things to remember is how to handle CSVs with comma in them and how to pass environment variables. So in this, if you don't want to use -v, you can also use the environ dictionary inside awk. So let us see how we can do that. So this is one of the correct solutions. If we now go and change the script.sh and we remove this v here, so we don't pass the year anymore directly to the script, so then the script will obviously not work. But now we can directly add it into the awk script. So we can change the script.awk, and here we can set the year to be equals to the environ of year. So make sure you're quoting the string, because this is a string and not a variable. If year was a variable, then it would have been working, but if you put a string here only, then it can take it as a key. So if you access the environment dictionary and access for the year, awk also automatically will give you the year value. So now if I run this, this will work correctly. So this is another solution by using the environment dictionary. We can also add the fpat in the awk itself. So we can have this in the script.awk itself. So we can set the fpat equals this, and we need to code the pattern correctly. So if I put the fpat in the awk script itself and remove it from the bash script, so our bash script is simply script.sh, then this directly we can run this script.awk and we can get the solution. So this is also a valid solution. So in this question, it could have also asked you to directly create a script.awk and you should still be able to solve this. However, the question was lenient enough to let you create a script.sh, and you can then either do everything in the awk or you can pass the variables from the script.sh itself. So that is how we solve the first awk question. So let's see how we solve the second awk question. So in this, you simply have to perform some statistics on a given data. So this is a very general thing that you need to do with awk, but there are some tricks in this. So for example, the data in this is always quoted. So for example, you can see the numeric values are also quoted. So we can have some CSVs which are not quoted at all, some CSVs which are partially quoted, so fields that have comma are quoted, and some CSVs like this which are always quoted. So in this case, if you're using some CSV parser, it will automatically decode it, but because we're using awk, it will, if you split directly by comma, it will directly give you the value which is quotation 78 quotation. So if you directly try to add those numbers, it will not work, and it will treat it as a string and give you the answer 0. So thus you have to first remove the quotation from the field. So let us see how we can do that. So first we have to use the gsub command to substitute the quotation and substitute it with nothing in the 6th, 7th and 8th field. So these are the math, reading and writing skills. We also set the field separator to be comma, because this is a CSV file and this is always quoted, and this does not have any quote inside any field. And we set the output format percentage to be 0.2f. So this is because our output should be in a 2 decimal places format. And we set the output field separator to be a tab. So now that we have replaced all the quotations with nothing, we can add the maths, reading and writing values, and we can also get the mean of each student. Then we also need to check if the student will, like if the parent of the student has gone into a school as the highest education or some college. So if it's a school, then we increment a count for school. If not, we increment a count for college, but we don't need to do that explicitly because we can directly subtract the number of rows from the school to get the number of colleges. And we are also checking if the mean marks got by that student is more than or equal to 80. So then we are incrementing a value. Otherwise, we are incrementing another value if it is for the student whose parent have gone to college and not to a school. And we are also keeping a count of the female. So in this, you cannot check if $1 is male, because if you are searching for male, then it will match for female also. And you also cannot add caret and dollar here because there will be a quotation also in that. So you can search for quotation male quotation and add male plus plus, or you can directly search for female because female will not match for male, whereas male will match for female. So we are then storing the number of females as well, and we can get the number of males by simply subtracting number of females from the total number, and then we simply print those averages. So math average is math by number, reading average is reading by number, writing average is writing by number. Female and male percentages are as follows, and the percentage of students who have their parents gone to college is NR minus parent school by NR into 100, and then we need to perform two probabilities. So we have to find a probability of a student getting more than 79 given that their parent have gone to college, and the probability of a student getting more than 79 given that their parent have not gone to college. So we also simply put in the values in the equation and get the solution for that. So this is how we solve this question. So a few subtleties to keep in mind are the quotations and the format specifier. So here you can see we have always set the output format to be 2 decimal entries. So in this you can see how the test cases are designed. So you can go to OPPE SE2001 base name PWD, and you can cat out all the test cases, and you can see this is the input that we get and this is the output. Similarly, this is the input for the next one and this is the output, and you can see almost always the probability of someone getting high marks is higher than someone getting high marks if their parents have not gone to college versus gone to college. So this is some kind of data analysis that you can do on this data. Let's see how we can solve the third OPPE question. So in this question you are given a CSV file and you don't care about the data, you only care about the headers, because if you remember the first question of OPPE had a lot of columns and it was very hard for you to count which column is which number. So this is kind of like a helper script which simply takes a CSV file and only prints the name of the column along with the number of the column. So as OPPE starts with 1, we should also start with 1. So this is a very simple question. So in this we set the field separator to be comma, and only for the first line, because only the first line is the header, we simply go over all the fields and we print the number of the field and the name of the print. So this is how we solve the third OPPE question. Let's see how we can solve the fourth OPPE question. So in this question also it was asked to access some values from the environment. So there are 2 ways of doing this. If you access it from the environ dictionary itself, you can directly do this without any script.sh, but for the ease of creating the solution, the question asks you to create a script.sh, and you can use only awk there, or if you want you can pass the variables using the -v flag. So in this question you're working on a data set, and the data should have n columns in each row, and the delimiter is also provided to you. So sometimes it's comma, sometimes it's colon, but the delimiter and the number of columns per row is provided to you. And however, you don't get the rows delimited by a new line, they are also delimited by the field separator. So your total data is just one line which has everything put side by side. So although for example in this there should be only 3 items per row, so the data should be like this: 1 2 3 4 5 6 7 8 9 10 11 12, but you get everything in one line. So your job is, given this data and the number of columns per row and the delimiter, so these two are given as bash environment variables, you have to then provide this correct output. So let us see how we can solve this question. So in this we have to use a script.sh. So this is so that we can easily provide the delimiter and the n. You can also directly use the environment dictionary to get these values, then you can directly do it in a script.awk. So in this we have first set fs equals the delimiter, so the delimiter is a comma or some other character, and we have set the field separator to be that value, and we have also given the value of the n into the awk script. So now in this, remember that we have to print only the first 3 in one line and then the next 3 in another line. So for doing this, we, instead of using the fs, we use the fpat. So if you are setting the fpat, it will automatically use the fpat instead of the fs. So here instead of fs we can also give this any other name like delimiter, but for sake of simplicity we have kept the name as fs. So the way we are creating this fpat is as follows. So in awk, if you put 2 strings side by side, it is a concatenation of the strings, so we don't have to use the plus symbol. So we are telling the fpat should be, it's a group of any character except the field separator character. So the caret means, caret inside the box bracket means any character except this. So this is any character except comma, present as many times as possible, minimum of 1, followed by the field separator, which is the comma. and this thing is then put in a group, and this entire thing is repeated n minus 1 times. So why n minus 1 and not n times? Because after the last column obviously we will not have a comma anymore, so there will be 1 comma 2 comma, and the 3 will not have a comma anymore. So anything that is not a comma, present as many times as possible, followed by a comma. This entire thing is present n minus 1 times, and then we again have anything that is not a comma present as many times as possible, but we don't have a comma after this. So if we set this as the f pat, awk will automatically take this one as the first pattern or the first field, this one as the second field, this one as the third field, this one as the fourth field, etc. Then we simply go over all the fields. So although we are printing this as these are individual fields and these are the rows, but to make this easy, in awk we are assuming each of these as one field. So 1 2 3 is one field, 4 5 6 is one field, 7 8 9 is one field, and 10 11 12 is the last field. So we are simply going over all the fields in that one line of data, and we are printing them on separate lines. So that is how we solve this question. Let's see how we can solve the final awk question. So in this question, it's asked that you have files that have carriage return line field as the line terminator, whereas you want the files as only line field as your line terminator. So you have to simply convert CRLF into LF. So you can do this with sed also, or you can do this with awk also. So the solution to this is pretty simple. We take our input record separator to be CRLF, and we take our output record separator to be only LF, and then we simply print all the lines. So this one will simply print all the lines. So try to understand why putting a 1 here prints all the lines. So if we have a condition here and we put braces and then there we type print, that means print the entire line for that condition. If that condition is, let's say, something like 1, so that is always true, and we have seen that in awk if we don't give the braces, that also means by default that print the entire line for that condition. So putting a 1 simply means print the entire line. So we simply set the RS and ORS and then we print each line. So that is how we solve the last question. So if you want to see what is the difference between the input and output, so it will not be visible to your naked eye. So for example, if you cat out all the test cases, you can see that the test case will look exactly the same. So the input and output will look exactly the same, but there is a CRLF in here and there is only a LF here. So you can see that by passing it through XXT. So you can see that by passing those into XXT. So I can simply pass, let's say, tc00.in, sorry, tc01.in, and you can see that here we have, after each line we have CR and LF. So we have carriage return and line field. So you can see it clearly on this line. So 0D is CR and 0A is LF. Whereas same thing on the output, it will only have LF. So you can see it only has 0A. So that is the difference between the input and the output.